everyone. So today we are going to start part 3 of complex number. Uh, in this chapter, we will see the geometrical representation of complex number. So like you see, we know a z value like x plus iy. Okay. So what is x? What is y? So we'll understand the geometrical meaning of that. Okay. So complex number basically, you know, it denotes a vector form. Let's say this point is O and this is P. It's a vector. Okay. This is x-axis and this is y-axis. Okay. So let's say I'm just taking one example. Let's say you have a z is 3 plus 4i. Okay. So this is the real part. Okay. And this is the imaginary part. Okay. This is real. These 3 and 4 are real values. Okay. So this 3 is x, right? So this axis you can call it, this is x-axis, right? You can call this distance as 3. Okay. And this value as 4. So let's say just use different colors. So this y, this is y-axis, right? So parallel to this is also y, this is y, this is also y, this is x, this is also x, which is 3. So like let's say y as 4. Okay. So you can see here that it's a Pythagoras theorem. Okay. As per, if you, this is the base, this is the perpendicular. Okay. So if you find the mod z of this value, so mod z is how much? Mod z is, we already know, right, how to find the mod z. Real plus real value plus imaginary part value square root. So that is coming 9 plus 16, that is nothing but 5, right? 5. So this will be 5. Okay. So your mod z will become 5. Okay. So this is the modulus. Okay. And if you want to find the amplitude value of z. Okay. So amplitude is nothing but the angle. Okay. Let's say we are finding the value of theta. So it's nothing but tan theta. Okay. Amplitude is z is equal to tan theta. Tan theta is how much? We know, right? Tan theta is y by x. So what is your y? What is your y? Y is 4. What is your x? 3. So your tan theta is coming 4 by 3. So your theta will become how much? Tan inverse 4 by 3. Correct? So whatever this tan inverse 4 by 3 will come, that will be your angle. Okay. Like anything it can come, right? Tan inverse 4 by 3. If you find, let's say, suppose I'm just assuming, let's say it's coming like 32 degree. So this angle will be 32. That is called amplitude of z. Okay. So this is the basics of geometrical representation of this complex number. Okay. We will, so basically will come, there can be polar form of this. Okay. Like let's say we can find, let's say I'm finding, you saw, right, tan theta is how much. Similarly you can find cos theta. Okay. So if you find cos theta, that will be how much? B by h. And if you find sin theta, that will come P by h. So your cos theta will be how much? Base is 3, h is 5, so 3 by 5. Cos theta is 3 by 5, and your sin theta will be how much? It will be P by h. P means perpendicular 4 by 5. Okay. So like that we can find the, I mean, there's a form called polar representation. Okay. By finding the value, you can find the polar representation of the, that is called polar representation of the complex number. Okay. You can even find that. Okay. So that is how much? That is nothing but z is equal to that is called r cos theta plus I sin theta. So what is r here? Okay. Let me use this color. So r is nothing but mod z. Okay. R is what? Mod z. Mod z we have already found for this value, right? That is 5. So you can write in this way: 5 cos theta is how much? cos theta just found out, right? 3 by 5. 3 by 5. Let me just erase this here. I will just write here. Okay. So let me just use this. I'll write here 5, 3 by 5 plus I sin theta. Sin theta is how much? P by H. That is 4 by 5. So 4 by 5. Okay. So this is what, like if you simplify this, so this 5 will, if you multiply this will cancel out, and 3 plus this 5 will again cancel out. If you multiply here, what it left, 3 plus 4i, which is nothing but z. So your 3 plus 4i can be written in the form of r cos theta plus I sin theta. Earlier you were not writing in this way, right? Earlier you're writing in x and y, but your x and y turns to be in theta format, right? In this geometrical format. Earlier x and y were real value. Now it is coming in geometrical form. So this is called polar representation of the complex number. Okay. So, and this whole plane where we are discussing this is called argand plane. Okay. Argand plane. Okay. We'll discuss more about this with the sums. Okay. But yeah, the basics you can just go through, and we'll do the sums in the next part. This is part 3. In part 4 and 5 of the complex number, we'll do a lot of sums based on complex number, whatever we have studied. Okay. And the sums will relate to RD Sharma and NCERT, which will range all difficulty level. Okay. From board to IITJ level. Okay. Yeah, practice whatever we have discussed. We'll see in the next class. Thanks.